Hello student, in this video we will discuss some examples on empirical formula and molecular formula determination. It is given that elementary analysis showed that an organic compound containing carbon, hydrogen, nitrogen, oxygen and weighing 7.3 gram was found to contain 3.6 gram of carbon and 0.7 gram of hydrogen and 1.4 gram of nitrogen. Then determine the empirical formula. So percentage weight of carbon, hydrogen and nitrogen is given and the total mass is given. Definitely 7.3 minus 3.6 plus 0.7 plus 1.4 gram. This will give the mass of oxygen present in this, right? In the next step, the carbon, this is hydrogen and this is nitrogen, and this one is oxygen. 3.6 gram of carbon, 0.7 gram of hydrogen and 1.4 gram of nitrogen and 1.6 gram of oxygen is given. So simple, by using the definition of empirical formula which gives about the simplest whole number ratio of the atoms of the element present in a given compound, we can find the moles of each. So this is 3.6 divided by 12, 0.7 divided by 1, 1.4 divided by 14 and 1.6 divided by 16. This will give 0.1, this will give 0.1, this will give 0.7 and this will give 0.3. On taking the simplest whole number ratio of this, what you will get? C3H7NO. This is the empirical formula of this compound. In the next question, find the empirical formula of hydrocarbon of 1.4 gram. This is the mass of hydrocarbon is given, which on complete combustion gives 4.4 gram of CO2 and 1.8 gram of H2O. As we know that to determine the empirical formula, first we have to calculate the mass of the respective element, then we will convert them into the simplest whole number ratio of the atoms present. So the 4.4 gram of CO2, it is used, this data will be used to calculate the amount of carbon present in that compound. So moles of CO2, definitely that should be equal to the moles of carbon will be 4.4 divided by 44, this will give 0.1 mole. Definitely the mass of carbon that should be present will be calculated by using that 0.1 into 12, that will be equal to 1.2 gram. Now the mass percent of carbon which is present in this hydrocarbon can be calculated by using that mass of carbon divided by mass of organic compound which is hydrocarbon is 1.4. Now we can calculate the moles of hydrogen present in this. Definitely the moles of hydrogen present in this will be equal to twice of moles of water. So because the 1 mole contains 2 moles of 2 gram atoms of hydrogen in this, so 2 into 1.8 divided by 18, that should be equal to 0.2 moles of hydrogen. So the mass of hydrogen present, that will be equal to 0.2 into 1, that will be equal to 0.2 gram. Again we can use the same formula to calculate the percentage of hydrogen, the mass of hydrogen divided by mass of hydrocarbon into 100, or we can say that when you will add this amount 1.2 and 0.2, you will get 1.4 gram. So to determine the empirical formula, the moles of carbon is 0.1 and moles of hydrogen is 0.2, and this data satisfied the given data also. So we can simply find the simplest whole number ratio of carbon and hydrogen. The empirical formula is determined as CH2. Right? We can take one more example to explain this. Find the empirical formula of hydrocarbon in which the amount is given as 3 gram, which on complete combustion gives 4.4 gram of CO2 and 1.8 gram of H2O. So definitely when you will observe the data in A part and B part, the amount of hydrocarbon has been changed while the amount of CO2 and H2O is same. So we can use the moles of carbon and moles of hydrogen in as same as in the above data. Definitely moles of carbon is 0.1 and moles of hydrogen, that will be equal to 0.2, and we can say that the mass of carbon is 1.2 and mass of hydrogen will be equal to 0.2. When you will add this 1.2 and 0.2, it will be equal to 1.4 gram. Definitely the 1.4 gram, when we will subtract this amount from this, you will get 1.6 gram, and according to the option, definitely this will be the mass of oxygen. Oxygen will be present in the empirical formula. So when you will add this amount, you will get the equal to 3 gram. So to determine the empirical formula, we can start to find the simplest whole number ratio of the atoms. So carbon is 0.1, hydrogen is 0.2 and oxygen is again 0.1. So taking the simplest whole number ratio of these three elements, what you will get the empirical formula, that should be equal to CH2O. We will take one more example to explain this concept. A compound of nitrogen and oxygen was found to contain 7:16 by mass of nitrogen and oxygen respectively. Now molecular formula is to be determined if the vapor density is 46. To determine the molecular formula, definitely we will use the relation that molecular formula is equals to empirical formula into n times. So it is required to calculate the value of n. So definitely vapor density is 46. So definitely when we will multiply this vapor density by 2, we will get the molecular mass, that should be equal to 92. To calculate the n, it is required to find out the empirical formula first, then we will find the empirical formula mass. As the nitrogen and oxygen is given in 7:16 by mass, yeah, we can say that by moles, definitely it will be present as 7/14 and 16/16, which is equal to 1/2:1. या सिंपली वी कैन से दैट इट विल बी NO2. अगर हम इसका सिंपलेस्ट होल नंबर रेशियो लेंगे, it will be equal to 1:2. So the empirical formula of this compound containing nitrogen and oxygen will be NO2. So we can find the empirical formula mass of NO2, that should be equal to 46. On dividing molecular formula mass by empirical formula mass, you will get N equal to 2. Now we can determine the molecular formula, which is equal to empirical formula, which is NO2 into 2, that should be equal to N2O4. So in this video, we have understood the concept of empirical formula mass and molecular mass. In the next video, we will start stoichiometry. Thank you very much.